Hey everybody, this is Mr. P again. This is your e-learning lesson for Algebra 1 for Wednesday, April 29th. And this is section 11.1, which is simplifying what we call rational expressions. And it will involve some factoring, which we did in our little factoring review for yesterday's e-learning. And let's define some things first. So what is a rational expression? Okay. It's the quotient of two polynomials. So quotient, basically we're looking at a fraction, right? A numerator and a denominator, right? Quotient means division. Of two polynomials where the denominator can't be zero, right? We can never divide by zero. Here's just some examples of rational expressions. Okay, so x squared plus 3x plus 2 over x plus 2, 5 over 2x minus 1, x plus 2 times x minus 2 over x. So those are all examples of rational expressions. This term excluded values. So these are values of the variable in a rational expression that would make the denominator zero. So therefore, as part of our answer, we state what values are excluded. In other words, what values of the variable cannot be true or cannot exist. Okay, so, and we do that by setting each of the factors, or all factors in the denominator equal to zero in order to find the excluded values. And we do that before we simplify, before we cross any terms out. So let's say we have our factored expression right here, x plus 2, x minus 2, and then denominator x plus 2, x minus 3. Before we simplify, we look in the denominator and we set the factors in the denominator equal to 0. So x plus 2 equals 0, which means x, and this slash through the equals means x cannot be equal to negative 2, right? Because that would make the denominator 0. And also, if I said x minus 3 equals 0, I would get x equals 3. So that means also an excluded value would be x equals 3. So sometimes we have more than one excluded value. Okay, so let's look at some examples. Alright, so first example. And for all these, we're going to simplify and then we're going to state what values are excluded. Okay, so let's say I have 4x minus 8 over x minus 2. So I need to factor the numerator and denominator completely. So denominator is already factored, there's nothing to factor there. You know, that's already simplified. The top 4x minus 8, so there's something I can take out of there. The greatest common factor, yes. Greatest common factor of 4 and 8 is 4, so I would pull out a 4. And I would say, okay, 4 times, and then dividing both of those by 4, right? If I divide that by 4, first term by 4, I'm just left with an x. Negative 8 divided by 4 is negative 2, so I have x minus 2, and then x minus 2 on the bottom. Before we simplify, let's go ahead and find our excluded values, right? So I would set that term in the denominator equal to 0, so my excluded value, I'd have x minus 2 equals 0. I would get x equals 2, which means x cannot be 2, right? That's an excluded value, right? That's part of our answer. The simplified expression, okay, so I see x minus 2 and x minus 2. Those terms can get canceled out, and I'm left with what? I'm just left with 4. So 4, that would be the simplified expression. And then when you're asked for excluded values, you would say x cannot be equal to 2. So x is not equal to 2. Let's try another one. Okay, so let's say we got 3x plus 6 in the numerator, and you have 3x minus 12 in the denominator. Okay, so if we look at that, we should be able to see that we can factor common terms out of both the top and the bottom. Okay, so at the top, common term of 3 and 6, common factor would be 3, right? So if I factor out of 3, divide both parts by 3, I get x plus 2. On the bottom, if I know common factor of 3 and 12 is 3, so I factor out of 3 and I would get x minus 4 in the parentheses. Okay, so before we simplify, let's do the excluded values. So excluded values, remember I said all the factors in the denominator equal to 0, so I would just end up setting x minus 4 equal to 0, which I would get x equals 4, which means x would not be equal to 4. So that's an excluded value. Remember, that's part of our answer. The simplified expression, what can I simplify here? 3 over 3, that just goes away, right? That just simplifies to 1. X plus 2 over x minus 4, that cannot be simplified anymore. So that would be my simplified expression, okay? X plus 2 over x minus 4. Okay, so we're going to go ahead and do some more examples. Again, we're simplifying, and then we're stating what values are excluded, values that make the denominator 0. All right, so let's say I have 3x in the numerator over, let's say it's negative 7x plus x squared. The first thing I want to do here is rearrange that so the x squared term's first, right? The highest power term we like to have first. So let's say 3x, and then I have x squared, then minus 7x. Okay, that looks a little better. Now, look at the top, nothing to factor out of the top. How about the bottom? Okay, so x squared minus 7x, both of those have what? They have an x. So let's factor out an x. So now I have 3x on the top still. When I factor out an x, I divide both of these by x. So x squared divided by x just leaves me with an x. Negative 7x divided by x, I'm just left with 7. So I have x and then x minus 7 on the bottom. So let's go ahead and do our excluded values. Right, so that involves setting factors in the denominator equal to 0 to see what values we can't have. So first of all, I would say, hey, x equals 0. That's actually one of my excluded values. So x cannot equal 0. And then I said x minus 7 equal to 0. Of course, I add 7 to both sides. I find, hey, x is equal to 7, right? Which means that x cannot be equal to 7. So these are my excluded values. X equals 0 and x equals 7. Both of those would cause the denominator to equal 0, which means that's why we exclude them, to get rid of them. Now, what can we simplify? I have an x on top and x on the bottom. Guess what? Get rid of those. And my final simplified expression looks like this. So I just have 3 in the numerator. In the denominator, I have x minus 7. So again, your answer, 2 parts of it, simplified expression, excluded values. All right, let's look at another one. Okay, so let's say I have x minus 4 on top on the numerator, and in the denominator, I have x squared minus 13x plus 36. So what am I going to have to do to the denominator? I'm going to have to factor it. Okay, so that's why we practice factoring in our e-learning from yesterday. So factors of 36 that add up to negative 13. So since that's negative, that's positive. Both would have to be negative. I'd find that that's x minus 9 and x minus 4. And on the top, of course, I still have x minus 4. Okay. Let's do our excluded values. Again, look at the denominator. My excluded values. We set both factors in the denominator equal to 0, right? So x minus 9 equals 0. Of course, we get x equals 9, which means x cannot be 9. Or x not equal to 9. And then I set x minus 4 equal to 0. Of course, if I add 4 to both sides, I get x equals 4. Which means another excluded value is x is 4, right? So x not equal to 4. And then, now I go ahead and simplify. I see an x minus 4 on top and x minus 4 on the bottom. Those go away. And actually, I would just be left with 1 on the top and x minus 9 in the denominator. Okay? So that would be my final simplified expression. 1 over x minus 9. Excluded values, x not equal to 9, x not equal to 4. Alrighty, so let's go ahead and look at another one here. And so I got x squared plus 20x plus 51. On the bottom, I have x squared minus 6x minus 27. And what we can see in both the top and the bottom, numerator and denominator, I need to factor. Right, so on the top I look for two numbers that add up to 20 and multiply to 51, so those are 17 and 3. So I'd have x plus 17, x plus 3 on top. On the bottom, I want factors of negative 27 that add up to negative 6, so, and of course I'd have to have one positive, one negative, since this is a negative number at the end here. So we're looking at x minus 9 and x plus 3, right? Those add up to negative 6, multiply to negative 27. Let's do our excluded values, okay? I'm just going to say EV, okay, excluded values. So x minus 9 equals 0. X equals 9 when I solve that. So x not equal to 9, that's one of my excluded values, 9. Then I do x plus 3 equal to 0. Subtract 3, so x is negative 3, which means x cannot be negative 3. So x not equal to negative 3. So those are my excluded values. What's my final simplified expression here? So what I see is that x plus 3 and x plus 3 would cancel out, which means I would have x plus 17 in the numerator, x minus 9 in the denominator. Okay, so that would be my final simplified expression. All right, let's go ahead and look at a couple more. Alrighty, so moving right along, let's say I have x squared minus 25, 5 minus x on the bottom. And again, typically we like to put the x first, then the variable. So let's just rewrite the bottom. So x squared minus 25 on top. Bottom, I'm going to change to negative x plus 5. Now we need to go ahead and factor. So x squared minus 25, hey, that's a difference of squares. We practiced one of those yesterday in our factoring example. So x squared minus 25, remember, 1's plus, 1's minus. So I would have x plus 5 and x minus 5, right? I'm thinking, what's the square root of 25? That's 5. On the bottom, when I have a negative in front of the x here, I need to factor that out. So I would actually factor out a negative 1. And if I factor negative 1 out of negative x plus 5, I actually end up with x minus 5. So divide both those terms by negative 1, the signs change. So I'd have x minus 5. And let's see, what do I have here? Okay, so let's look at excluded values. So I know the only thing I need to set equal to 0 in the denominator for excluded values is x minus 5, right? So x minus 5 equals 0. So add 5 to both sides. So x would be 5, which means, hey, excluded value, x cannot be 5. Right, that's part of our answer. Go back to simplifying, so we know x minus 5, they go away. And what do I have here? I have x plus 5 over negative 1. Okay, so remember, dividing by negative 1 is the same as multiplying by negative 1, basically. So I would have negative 1 times x plus 5, and I would redistribute that, so I would end up with negative x minus 5 when I distribute that negative 1. So that would be my final simplified expression, okay, where x cannot be equal to 5. All right, let's try one more. So, let's say I have 3t minus 21 over 49 minus t squared. Okay. So first thing, let's rearrange the bottom, right? When we have a quadratic, we want to have that squared term first. So let's just leave the top alone for now, 3t minus 21. So I'm going to change this to negative t squared plus 49. Again, same thing, except I just rearrange the terms. So factoring. Let's look at the top. Is there a common factor of 3 and 21? Yes, it is 3. Right, so I factor out a 3. Remember, dividing both terms by 3, I would have t minus 7 in the parentheses. On the bottom, remember, whenever I have a negative in front of the first term, I want to factor that negative out. So I'm factoring out a negative 1 is what I'm doing here. And I'm left with t squared minus 49. Okay. And let's see. Well, t squared minus 49, that's another difference of squares, right? So think of what the square root of 49 is. 7. And remember, difference of squares is always one's a plus, one's a minus. So I have 3 times t minus 7. And then at the negative 1, I have t plus 7, t minus 7, like that. Okay. So let's do our excluded values. So look at the denominator once we factored it before we simplified. So our excluded values, right, we set the factors in the denominator equal to 0. So I do t plus 7 equals 0, t minus 7 equals 0. So here I get t equals negative 7. So t cannot be negative 7. Add 7 here, so you get t equals 7, which means t also cannot be 7. So these are excluded values. Again, that's one part of your answer. The other part is a simplified expression. So what's going to cancel between numerator and denominator? What do they have in common? T minus 7. Cross those out. So I'm left with 3 over negative 1 times t plus 7. All right. So a couple different ways we could write that answer. Okay, so one way I could distribute that, right? You'd have 3 over negative t minus 7, or I think a more common way, we could just go ahead and put the negative in front, so I could have negative. You just put the negative outside of the fraction, so negative then 3 over t plus 7. Okay, so those are two different ways you could write the answer. And actually, you could probably also do negative 3 over t plus 7, right? Since you have 3 over negative 1, that's negative 3. So again, just different ways to write that answer. Again, probably more commonly you're going to see something like this, where you have the negative in front, and then you have 3 over t plus 7. All right, so that's all for today. Tomorrow's e-learning will actually be a review assignment, okay, for 11-1. See you later.